Good morning. Today we're going to do lesson 30. It is a big lesson. We're going to graph the tangent function, and then we're going to graph reciprocal functions. Before we graph reciprocal functions, let's just remind ourselves what that is. The reciprocal of 0 is going to be undefined. The reciprocal of 1 is 1. The reciprocal of -1 is -1. And in this case, the reciprocal of undefined then will be 0. We're going to use these as our markers to graph our reciprocal functions. So let's start in our pursuit of graphing the reciprocal function of sine. We want to graph the cosecant function. We start by graphing sine. Take note that at 0, sine is 0. At pi, sine is 0. At 2 pi, sine is 0. At pi over 2, sine is 1. At 3 pi over 2, sine is -1. So let's consider the reciprocals of those values. I'm going to use a different color marker to graph cosecant of x. The reciprocal of 0 is undefined, so there will be an asymptote there. The reciprocal of the reciprocal of 0 at pi is undefined, and at 2 pi sine is 0, and the reciprocal of 0 is undefined. Now, let's remember that we have 1 at pi over 2. Reciprocal of 1 is 1, so that will be part of my graph. The reciprocal of -1 is -1, so that will be part of my graph. The reciprocal of a small number is a larger number. The reciprocal of a small number is a larger number. And if we start over here, reciprocal of a small negative number will be a smaller negative number. We see this. Remember what we learned last week at the asymptote, the function jumps, going through the markers. This is a periodic function, so this will carry on forever in both directions. Notice the cosecant function is what is in green. When you graph these, you are welcome to graph the sine function as a guideline to graphing the cosecant function. You can use different colors, or you can erase the sine function, but you do need to make sure you designate your answer. So let's consider the reciprocal of cosine then. The reciprocal of cosine is the secant function. So again, let's find the values of cosine that we're going to use for secant. The reciprocal at 0, cosine is 1. At pi over 2, cosine is 0. That's important. At cosine of pi, cosine is -1. At 3 pi over 2, cosine is 0. And at 2 pi, cosine will be 1. So let's consider the reciprocals of those. The reciprocal of 1 is still 1. The reciprocal of 0 is undefined. Reciprocal of -1 is -1. Reciprocal of 0 is undefined. Reciprocal of 1 is 1. Reciprocal of a small number is going to be a large number. Again, if we start from the right, at the asymptote it jumps, goes through that value but does not cross, and then it jumps at this asymptote and it goes here. This is just one section. This is from 0 to 2 pi. Again, the secant function is designated in green. We know that it carries on in both directions. And you can designate your answer either using a different color or labeling. So let's consider the tangent function. The tangent function then, we already have asymptotes in the tangent function. I hope this is clear enough for you. But we know that the tangent of 0 is 0. The tangent of pi over 4 is 1. Tangent of pi over 2 is undefined. Tangent of 3 pi over 4 is going to be -1. Tangent of pi is 0, and so on. If we connect these, we see the tangent function. Again, starting from the right, jumping at the asymptotes, crossing the x-axis at the 0, and we know as it goes on forever in both directions. But what about the cotangent function? Again, let's use our markers. The reciprocal of undefined in this case will be 0. The reciprocal of 1 is 1. The reciprocal of 0 is undefined. The reciprocal of -1 is -1. The reciprocal of the reciprocal of undefined is 0. The reciprocal of 1, and the reciprocal of 0 is undefined. The reciprocal of -1 is -1. The reciprocal of undefined is 0. The reciprocal of 0 is undefined. The reciprocal of 1 is 1. So let's consider what this looks like. Starting this side, okay, we can see jumps, crosses at the x-axis, jumps, crosses at the x-axis. Yes, it begins to look pretty fun. And we have an asymptote there. Again, designating your answer with a different color. Very pretty. Okay, what about the translated functions? The translated functions, you can graph the original function, and if it's translated 20 degrees in the positive direction, then I know this will be 20 degrees. And then I'd add 20 degrees to each of my scale, easily translating each function. So the second part of this is going to be functions of x, not trigonometric functions. We're going to use the same process. So in this example, we are given that f of x is this line. Again, you need to find your zeros, your ones, and your asymptotes. And you need to consider what that's going to look like. So we see that at 0, we have a 1, right, a -1. Reciprocal of -1 is still -1. At 2, the function is 0. Reciprocal of 0 will be an asymptote. And roughly at 3 or 4, when x is 4, the function is 1. So the reciprocal of 1 is still 1. And let's consider what this looks like. Again, we start from the right, going through the marker. At the asymptote, it jumps. There is no 0 to cross. Going through the other function. This would be the reciprocal function of f. Find your ones here and here. Find your zeros. The reciprocal of 0 will be an asymptote. The reciprocal of 1 is 1. The reciprocal of -1 is -1. So let's look at one that's a little bit more complicated. Given that we have f of x here, let's do this very methodically. We have a 0 at 2. When x is 2, the function is 0. Reciprocal of 0 is undefined. We can see that at 3, looks like we have a 1, so we know at 3 we're still going to have a 1. Looks like at 1 we have a -1, so at -1 we're still going to have a -1. Looks like there's an asymptote at x equals 0, so we know we're going to have a 0 at 0. And at -1, we have a 0. When x is -1, the function is 0. Reciprocal then would be undefined. We see that we have a 1 partially in between here, halfway. So we know we have that. Then at -2, looks like we have a -1, so that will remain. And at 3, we have a 0 at -3. Reciprocal of 0 is undefined. Then at -4, looks like we have another 1. So we have that. When x is 2, the function is 0. So at 2, we have an asymptote. When x is 3, the function is 1. Reciprocal of 1 is 1. When x is 1, the function is -1. The reciprocal of -1 is -1. When x is 0, we have an asymptote. We have undefined. Reciprocal of undefined is a 0, and so on. Starting from the right, just like we learned last week, jumps at the asymptotes, crosses the x-axis at the zeros, jumps at the asymptotes, no place to cross, turns around, jumps at the asymptotes, goes through the 1. We can see that there must be a horizontal asymptote as well. Alrighty, try those. Send me any questions that you have. You may text me. Please tell me who you are, what lesson number, and what question you have. Be assured that lesson 31 will be very brief. All right, I hope you're having a great day.